Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Huda binti Sharif, and I will explain about the introduction in fluid mechanics. A material's density is defined as its mass per unit volume. The principle of density was discovered by the Greek scientist Archimedes, and it is easy to calculate with the formula and its related units. To calculate the density, the formula is ρ equals to mass per volume. The SI unit of density is kilogram per cubic meter or grams per cubic centimeter. Density is also an intensive property of matter. This means that the value of density is independent of the quantity of matter present. This is in contrast to extensive properties like volume, which depend on the quantity of matter present. The more matter present, the larger the volume. Archimedes' principle refers to the force of buoyancy that results when a body is submerged in a fluid, whether partially or wholly. The force that provides the pressure if a fluid acts on a body perpendicular to the surface of the body. Next is the theory. In density, a physical property can be measured without changing the chemical identity of the substance. Since pure substances have unique density values, measuring the density of a substance can help identify that substance. The formula of density is mass per volume, and the units are commonly expressed as kg per meter cube for solids and kg per liter for liquids and gases. For buoyancy and Archimedes' principle states that a body wholly or partially submerged in a fluid is buoyed up by a force equal in magnitude to the weight of the fluid displaced by the body. It is important to remember that fluids includes liquids and gases. This force is given by Fb equals to rho Vg, where rho is the density of the fluid, V is the volume of fluid displaced, and g is acceleration due to gravity. Thus, the net force of a totally submerged object is F net equals to Fb minus Fg equals to rho F Vg minus rho 0 Vg. If the density of the object, rho O, is greater than the density of the fluids, then the net force will be negative or downward. In this case, the object will sink. If the density of the object is less than the density of the fluid, then the object will float. The objective of this experiment is to determine the density of liquid, which we use vinegar, to calculate the buoyant force for different types of materials, and to understand the concept of density, Archimedes' principle, and buoyant force.
Hi, my name is Aida binti Hanizam with ID number TH20059. So, in my part, I would like to present about the apparatus and methodology. So, first is for the apparatus. In this experiment, we use an electronic balance, beaker. So, for the three metal, we use the copper for the coin, silver for key, gold for ring, and vinegar. Okay, so for this experiment, we have a part one which is determining the density of fluid. So we use vinegar instead of the oil. So for the first step is the mass of dry beaker was weighed by using an electronic balance. So make sure the beaker was dry before we weigh it. And next is 25 ml of vinegar was poured into the beaker. And for the third, the volume of liquid was recorded and the combined mass was measured by using an electronic balance. And another 25 ml of vinegar was added into the beaker. So the volume and combined mass was measured by using an electronic balance. So for the last step, last but not least, step 2 until step 4 was repeated until at least 7 sets of mass and volume measurement we obtained. That's for the part 1. So we will move on to the part 2, which is we determining the buoyant force for an object. So in this experiment, we use water to determining the buoyant force. So we still use the copper for coin, silver for key, and gold for ring. So for the part two, firstly, water was filled partially inside the beaker to make sure the object was completely covered. Just make sure the water is enough to completely cover the object. So for the second step is we record the initial volume of the water and submerge the copper, which is coin, into the water. And for the fourth is the new water level, which is after we submerge the object, it will increase the water level. So the water level, which is the VF, was recorded and the change in volume was calculated. Next, step 2 until step 4 was repeated by using silver, which is a key, and gold for ring. So step before this, in step from the step 2, we repeat, but we replace it with step 2 until step 4 was repeated by using silver, which is a key, and gold for a ring. To determine this procedure, to determine the buoyant force for an object. So that's all for the part 2.
Hi, my name is Heng, and my ID number is TH21051. So today I'm going to continue the presentations by the results of our group obtained from this experiment, which is the first part, determine the density of the fluid. So before we determine the density of the fluid, we have to know the volume of the fluid obtained. So for the first one, we measure the mass of the cylinder itself, which is we measure it as 58 grams. So initially there is no any vinegar inside the cylinder, so we label it as 0. However, after we add the vinegar inside, we started off by consistently adding 20 cm cube each time until we got 7 recording results. So 20, 40, 60, and 80, and the result of the mass that we get is 78, 96, and 114. So until the last 116, we get the result, which is the increasing result of each time. So hence it is safe to assume that the mass increases as the volume increases for the vinegar that we choose as the mechanical fluid. So by determining the density of the fluid, which will be explained by my next teammate, which is Elizabeth. So before that, we're going to continue with the next slide. Continue to the part 2 of the result, which is by determining the buoyant force of the object. So in this experiment, we used our container, which is very small, hence we have to weight the weight of the container itself. So before we start the experiment, we have to weight the container, which is the result we get is 6 grams. Well, so after the experiment is conducted, we have to minus out the weight of the container itself. So in this experiment, we also use the weight balance to measure the mass of the volume. So this is because the theory stated that the 1 gram of the mass object is equivalent to 1 cm cube. Hence, we use this comparison to put it as our volume. So there are 3 objects that have been categorized, which is the copper, silver, and gold. So these 3 objects, we have to find out the buoyant force of the object. So we have to find the water that displaced through by the object when you put inside the water. So for the first copper coin, initially the volume is 10 cm cube without the copper coin. After we put the copper coin, it only shown the final result is 11 cm cube. So the change in volume is 1 cm cube. Hence, 1 cm cube of water has been displaced. Second one is silver key. Silver key, initially without the silver key, the water is 21 cm cube. After we add in the silver key, the final volume of the water is 25 cm cube. Hence, the displacement of water is 4 cm cube. And lastly, gold ring. The initial is 23 cm cube and the last is 24 cm cube. Hence, the displacement of water is 1 cm cube. Therefore, we can conclude that the result of the displacement of water is silver key is the greatest, while the gold ring in copper coin is the same. So, to determine the buoyant force of the object, I will pass it to my teammate also Elizabeth. Will also present about the determine of buoyant force and also to find the density of the mechanical fluid, which is the vinegar. Thank you. That's all for me.
Hello, my name is Aviefilah and my metric number is TH244. So I will continue with the discussion part, which the part 1 is we need to identify the density, which as you can see at the slide, the formula is density equals to mass over volume. So the theoretical for the vinegar is 1.006 kilo per liter, and the density that we got from the graph, which is the calculation one, is 0.9075 kilo per liter, and the percentage difference is 6.81%. As for the part 2, which we need to find the buoyant force, which as you can see in the slide, there is a formula for buoyant force, which density of the liquid multiply with the volume displaced and acceleration due to gravity, which is we can write it as Fb equals to V rho g. So the result that we got is the copper coin. We got the buoyant force is 9.7806 power by negative 3 Newton. As for the silver key is 0.03912 Newton, and the last one is gold ring, as we got its buoyant force is 9.7806 power negative 3 Newton. So as for the discussion, the greatest buoyant force that we got in part 2 is the silver key, if we compare to the copper coin and the gold ring. That's all from me. Thank you.
For conclusion part, me, Elizabeth, will present this part. To summarize this experiment, the displaced fluid equals the submerged volume. To float or partially submerge an object, its weight must be less than the weight of the fluid that can be displaced by the object. In contrast, if the object weight is greater than the weight of the fluid that can be displaced by the object will sink. Otherwise, the object will be fully submerged if its weight equals the weight of the fluid that can be displaced by the object. To conclude, the results from this experiment support the fact that the relationship between specific gravity, density, and buoyant force that can be tied to the definition of Archimedes' principle.